Let's take a look at some fun ones in part 2. We're going to solve this one just like any other normal algebra equation. We're going to treat the secants like they're a variable like x. So we have to combine them on the same side. So we're going to bring this secant over here, and that's going to give me 2 secant theta plus 12 equal to 21. See, just like another algebra equation. And then to solve for the secant of theta, we're going to subtract the 12, so we get 2 secant of theta equals 9, and then just divide by 2. So we get the secant of theta equals 4.5, because 9 divided by 2 is 4.5. Now remember, we can't solve secant, but we can do cosine. So to solve this one, remember, we're going to do, before we switch them, we should write this as the cosine of theta equals 1 over 4.5. And I just solve it. Theta, the reference angle, is the inverse cosine of 1 over 4.5. And let me see, give myself some bit of space here. Remember, cosine is positive in 2 quadrants. It's positive in quadrants 1 and 4. And that's what I'm going to solve here. Remember, my reference angle will give us the first quadrant. But if I type that in, just go, remember, make sure you're in the right mode. I think this time we are in radian mode, so we're okay. Doesn't say, but we should be in radian mode because it's the last section. Second cosine 1 divided by 4.5. I hit enter, give me 1.35. So there's my reference angle. Remember that it's already in quadrant 1. So that gives me my quadrant 1 angle, 1.35 radians. Now to get quadrant 4, remember, we got to kind of think a little bit. This is the angle we're looking for. So this is the angle we're looking for. So we're going to take this, there's my reference, we're going to take 2 pi minus our reference angle, 1.35. And that's pretty easy to do. 2 pi minus 1.35. And that gives me an angle of about 4.93 radians. There we go. Now, number 10, my all-time favorite. It says 3 cosine squared minus 2 cosine theta minus 1. All that time you've been wondering, when would I ever use factoring? Here it is, ladies and gentlemen. We have to factor this. But we can't factor cosine necessarily. But we can factor if I switched it like this. 3x squared minus 2x minus 1 equals 0. Now, if you have trouble factoring, ask us in class. Come to a tutorial, okay? But when you factor this one, pretty easy to do. We're going to get 3x and a 1 and an x and a 1. I want negative 2, so this becomes negative. This is positive, equal to 0. Solve it just like normal. We're saying x equals negative 1/3. Here we get x equals 1. The only difference is we're not using x. Remember, we replaced cosine with x. So this becomes the cosine of theta equals negative 1/3. And this becomes the cosine of theta equals 1. And what makes this really fun, you could have up to 4 answers. Because just for this one alone, we're going to get different answers, okay? Because cosine is negative in 2 quadrants. Cosine is negative in the second and third quadrant. So we get our angles. Remember, to get the reference angle, make it positive. We're going to go second cosine 1/3. Keep it positive. Keep it positive, okay? And remember, this is my in my first quadrant, okay? So my reference angle here, and I should write down some room here, my reference angle is 1.23. So to get my second quadrant, we're going to take pi minus 1.23. And if I do that, second pi minus 1.23, we get 1.91 radians. To get my quadrant 3, we do pi plus 1.23. I know it's kind of hard to see there. We go pi plus 1.23, and we get 4.37 radians. Now, the last one's not that bad. Where is cosine theta equal to 1? Remember, this is just saying inverse cosine of 1 equals theta. And this is actually not too bad to do because we already know this answer. Where is cosine equal to 1? Of course, theta equals 0 radians and 2 pi radians. And there's our 2 answers. That one we should already know. All right, well, that's part 1 and part 2.